I'm back again, forming of a rule in geometric patterns. Again, I have Mrs. van der Westhuizen's paper. Now this one's a little bit different. I have a picture of matchstick houses. Now when they give you this, immediately you must count what happens in pattern number 1. Diagram 1 is pattern 1. So we count 1. I'm going to mark it as I count 1, 2, 3, 4, 5, 6. 6 matchsticks were used. Let's count the next pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 matchsticks were used. Counting the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now the reason why I marked the sticks is that if you don't, you might undercount or overcount, and that causes a truly silly error. Now before we can go any further, we have to decide a rule that makes this happen, because there's no more drawings to count, so we have to figure out what happened to the 1 to get to 6. And then you have to test that rule. Well, 1 plus 5 is 6, okay? So, 2 plus 5, 9. That's not working so well. So, let's go back. What if I said 1 times 5? I get 5, but I actually need 6. Let's add 1. So over here I'm going to say 1 times 5 equals 5, and then I'm going to add 1, and I'm going to get a final answer of 6. Okay, that worked. Let's apply the same rule here. So we say 2 times 5 equals 10. Adding 1, I'm getting 11. That sounds pretty good to me. Let's try it with pattern number 3. 3 times 5 is 15. Add 1, I get 16. Clearly, you can see what the rule is now. I times by 5, and then I added 1. So I'm going to highlight the first operation, which is times 5. And then I'm going to highlight the second operation, which is plus 1. Now, because we have a rule, and it did work in the first pattern, the second pattern, and the third pattern, we can continue to work this rule to find the rest of our missing numbers. 4 times 5 is 20, and 20 plus 1 is 21. 5 times 5 is 25, plus 1 is 26. 7 times 5 is 35, plus 1 is 36. 12 times 5 is 60, hope you know your tables, plus 1 is 61. Well, that went pretty smoothly. Now, here we had the number, we followed the rule times 5 plus 1, and we got our number of matchsticks. But now we have the number of matchsticks, we need to know what place or what pattern down the line is it. In order to do this, we have to do the opposite. Opposite means inverse. We have to make the rule opposite. We have to do the inverse of the rule. So if I went from 12, I times and then I'm adding. So now I need to do reverse. I need to say 101 minus 1 gives me 100. So I've done the inverse of that. Then I must do the inverse of that. So 100 divided by 5 is going to give me 20. Let me put 20 in. Let it stand out. Now let's check the rule. Does it work? 20 times 5 is 100. Fabulous. Add 1, and I get 101. Therefore, it is correct. Now at the bottom, the rule has been written very basically. As you get older and your math becomes more complicated, it will be written differently. But first, x is the position. So x can be 1, x can be 2, x can be 3, x can be 4, x can be 5, x can be 6, x can be 7, x can be 12, and x can be 20. In fact, x can be any number on the top line. We're then going to multiply it by 5, which is the first part that we did. And don't change the order of your rule once you start working. Plus 1. So x is any number on the top line. It's the pattern number, pattern 1, pattern 2, pattern 3. Multiplied by 5. Then we add 1. And the output, which is y over here, is actually the number of sticks that would be used to make the drawing. So in drawing 1 we use 6, but in pattern 20, drawing 20, there would have been 101 matchsticks used. I hope that simplified it for you. Cheers.